Well, good afternoon, everybody. Thank you for joining us. Today's presentation is on the Fairfax County typical deck details, which is based off of the current Virginia Code, the 2018 Virginia Construction Code. Some of the things that we're going to cover today, I want to really emphasize, and this is going to be a reoccurring theme throughout the presentation, defining the scope of the typical deck details. There are many ways to build a code-compliant deck that are outside of the scope of the details. But what we're covering today is the deck details. And I'll highlight some of those as we go through the presentation. But we're also going to learn how to navigate the document, discuss all kinds of different methods and materials that are approved through the document, and then also practice manipulating some of the charts to cover how to go through the detail. A lot of notes here. But they are important. It helps frame what we're doing. The details are based on multiple different documents. They're based on the residential code, the 2018 residential code. They also take into consideration the NDS, which is the National Design Specification for Wood Construction, as well as different evaluation reports for certain products. All those went into consideration when designing the this publication. The use of these details to design multi-level decks is prohibited. And when we talk about multi-level decks, we're not necessarily talking about two decks that are side by side that are at different elevations. We're talking about like two-story decks where you have a deck and then, you know, on the second story you have another deck. And the reason for that, the reason why it's prohibited isn't that the joist spans change, it isn't that certain beam sizes change. A lot of it has to do with the footings. You're carrying twice the load on those footings, so those footings aren't going to work. It also doesn't take into consideration if you're trying to use a single post all the way to that second deck, you're notching that post in multiple locations. And you have to take that into consideration when you're designing those posts. Other things that are outside of the scope of the deck details include privacy screens, planters, built-in seating, and surface-mounted guardrail posts. Again, all those can be designed. You would just have to submit plans. So you're going to hear me talk about plans all afternoon, but those are all outside of the scope of the deck details. Your fasteners, your hardware, and mechanical connectors, those all have to be approved for pressure-treated wood. Flashing, which we'll get into more in depth later on, has to be made from material that chemically can be mixed with the pressure-treated wood. We also have, PVC decking and guards. Even though those are manufactured products, they are approved under the deck details. However, you have to be able to provide an evaluation report to the inspector at the time of inspection. Every reputable manufacturer of these products has gone through the testing and has an evaluation report that shows compliance with the code. Anything outside of that, give us plans. So, decking. 3 types of decking is approved. We have 5-quarter wood, you have 2x4s or 2x6s, and then you have your plastic composite PVC materials. With your 5-quarter boards, if it's on an angle, your joist spacing has to be 12 inches on center. That wood is not thick enough to span more than 16 inches. So once you go to that angle, you have more than a 16-inch spacing at 16 inches on center. 2x4, 2x6, that's where you can go 16 inches angled or 24 inches on center if it's perpendicular. And then your composites, another reason why those evaluation reports are so important, they're going to tell you exactly what your spacing is on for that product. Because when you look at the PVC and composite material, you can have very vastly different sizes, profiles, that have different spans. Fasteners. When you're face fastening this material, you're using 2 8D nails or number 8 screws at each joist. At the time of installation, depending on the material, the moisture content of the material is going to depend on whether or not you're putting a gap in your spacing. If the material is wet, and there really is no way to tell you right here and now what condition your material is going to be in, that will encompass every situation. The time of year affects the moisture content. Obviously the weather, if it just got rained on, even if it's under a tarp, if it just got rained on, there's going to be extra moisture in that wood. So that's going to be a site-specific application when you go to do your project. You also have the option of hidden fasteners. Hidden fasteners have grown in popularity because they offer that sleek look to your deck with no fasteners. There are a couple rules or additional requirements when you use hidden fasteners, such as the bracing on the underside of the joists. The reason why is when you have the deck with face nails, face fasteners and everything, you've tied every deck board into every joist, and it prevents racking of the deck. When you're using the hidden fasteners, it's based off of a tension capacity. It's just gripping, and it doesn't provide the same hold down capacity as the face fasteners. So the 2x6s underneath still tie in all those joists to prevent that racking. Safety glazing. This is always a fun one, but it's not as prevalent on every job site, but it is something to keep in mind when you're planning your deck. There are certain areas, certain windows, even if they're not, even if you have a deck at your house now, and you have a situation where you have a window that's required to be glazed and you're replacing your deck, you may still be required to fix that window, even though it is, even though you're rebuilding your deck in the same place. If it's in the walkway, you see up to 36 inches up to 36 inches high within 60 inches of the landing at the bottom of the stairs. You have that hatched area, which is the hazardous area. If any part of that pane is within that area, you have to replace that pane to make sure it's tempered. The top pane, it wouldn't be required. It's based on the individual pane, not the window. So if you have a double pane or a double sash window, the top sash wouldn't be required, but the lower sash would. Those are at stairs. The other place that you might have an issue to require safety glazing is going to be if you have a window that is over 9 square feet and it has to meet all 4 of these requirements. It's over 9 square feet, it's less than 18 inches to the floor surface, more than 36 inches high, and within 36 inches of the walking surface. So if it's at the deck, that obviously takes on the 36 inches of the walking surface. But again, if it doesn't meet any one of those 4 requirements, it's not required to be safety glazed. So you could have a window that's over 9 square feet, but it's 24 inches off the walking surface. You're exempt. Now, does it inherently make it any less safe? That's 6 inches? Not necessarily, but it's not required by code to be. So yes, if you have a patio door, it would also be required to be glazed. Now, hopefully, any patio door you have is already glazed, but if for some reason it's not, then, but that was a good question. Thank you. Electrical. Every deck is required to have an outlet. That outlet is required to be within 6.5 feet of the walking surface. The other requirement is that it has to be within the perimeter of the deck. So if you're constructing a deck and that outlet is 6 inches outside the guardrail, that is not a compliant outlet. That has to be within the perimeter of the deck. That 6.5 feet does, though, mean that it can be, it can be up at the top of the floor above if that's within 6.5 feet. The other electrical requirement you have for decks is that stairways are required to be illuminated. They can be motion detectors, they can be controlled by interior switches, they can be low voltage, they can be solar. Fairfax will even consider solar if you have a situation where, say you're doing a freestanding deck out, and getting electrical there would require some extra work. We'll consider solar to meet that requirement. Essentially, the amount of light that you have to have on those stairs, you just have to be able to see the stairs. It's not, you don't have to be able to read every knot or see every knot that's in the wood, but you do have to be able to see where you're walking. Joist span lengths are measured from the ledger board to the center line of the beam or center of beam to center of beam. And joists are permitted to overhang past a beam, and that does not count towards your joist span length. On this table here, we're covering joist spans as well as your overhang. Now, we look at maximum overhangs. For a 2x12, you're allowed to span 18 feet with a 4'6" overhang. However, that overhang cannot exceed 1/4 of your joist span. So if you only go 12 feet with your joist span, you can't go that 4'6". You're only able to go 3 foot. Blocking. When you have an overhang, you're required to put blocking above in a drop beam situation, and we'll talk about drop beams versus flush beams here in a second. In a drop beam situation, you are required to block in between the joists at the beam location. The purpose of that is you're trying to prevent rotation of the joists. So you have to put blocking up to 60% of the joist height at that location to prevent that rotation. A couple other notes about joists. When we talk about guards, when we talk about your guardrails, guardrail posts cannot be attached to 2x6 joists. So that would be, unless that deck is less than 30 inches from grade, you're going to have another design consideration if you choose to use 2x6 joists. You also have a minimum of a 2x8 ledger, which we'll talk about, in which case you would have a difference in your ledger height versus your joist height. So when you're building a deck, not every situation is going to be perfect. You're going to have situations where you might have a chimney, you might have a bay area on the existing structure. We have a single solution for that scenario. You can only come out, it can only project 3 feet into the deck, and you have to have a triple trimmer joist. So even if it's not maxed out at the 6 feet and it's only 2 feet, this is the single solution for projections into the deck. You have to have a triple trimmer joist and a 2-ply header. You also have some requirements for the fasteners into the ledger attachment as well. You have to have some extra fasteners on the inside of that connection. So as you're framing it up, you have to make sure that you're not going so far, so close to that projection that you can't get those fasteners in there. And if you do, so you can use a concealed flange hanger, but if you get so close that you're not able to get those bolts in there, you're either going to have to reframe it or get a design and submit plans. And again, the whole point of this document is to avoid the plans. There are plenty of code compliant ways to get there, but our goal is to avoid the plans. The detail also gives you a 6 inches. So it's not that you have to get it, it's not like you have no tolerance at all. It'll give you 6 inches that you can overhang your deck boards. So you have plenty of room to get in there and get your framing around. Joist hangers are phenomenal. However, there are a lot of things that people try to do that are not allowed with joist hangers. That joist hanger has to cover that 60%. It's the exact same principle. We're trying to prevent that rotation. If you don't cover enough of the height of that joist, it will rotate. You cannot bend or manipulate the hanger outside to accommodate field conditions. And this one here, in this picture here, they've notched the hanger around a through bolt. That hanger is no good anymore. You also cannot use these metal clips here. That is not what they were intended for. These clips are intended for a vertical connection, not a horizontal one. The most common place we see that clip is on that end joist. One other commonly failed item for hangers is the wrong fastener used at the connection. Most of these hangers have what we call a double shear connection, and that's a fastener going in at an angle. When it goes in at that angle, it has to be long enough to go into the header or the ledger board. So it's going to be longer than the 1.5 inch nail that you can use for the face connection. The inspector will ask you about those. Your joist to beam connections. There is a code compliant, it's in the code book, there is a code compliant method without using a mechanical fastener. And it is perfectly code compliant. That is outside of the scope of the deck detail. Every joist to beam connection in the deck detail requires a mechanical connector. Now, that could be the H2.5A, like you see right here. It just has to be a mechanical fastener. All right, skill check. We have a freestanding deck. The joists are 16 inches on center. We have an 11-foot, 6-inch span between the beam and the ledger. We have between the beams. A 2-foot overhang at the house and a 2-foot, 6-inch overhang at the front of the deck. Can you go ahead and try to size that joist for me? Okay, so for our answer, if you go 16 inches on center, you have an allowable span of 11 feet 10 inches, which exceeds our 11 feet 6 inches in the example. However, you have that 2-foot 3-inch cantilever, which works for one side, but it doesn't work for the other. So we're going to have to go up one size to a 2x10. One nice thing about this detail is there are definitely some restrictions, but it also allows you to, move your deck around and see really where you can maximize your spacing. If you really say you had a great deal on those 2x8s and you didn't want to go to a 2x10, there is some flexibility in there. So beams, the most important term when we're talking about beams is this influence width. And when we're talking about influence width, we're talking about what weight is this beam actually carrying. So in that top left example for outside drop beam, it is half the distance between your supports. So we have our ledger connection at the house and our beam, it's half that distance. It's carrying that weight of the joists plus the overhang. If you have a situation where you don't have an overhang, like the outside flush beam, it's just half that distance. So that influence width is going to be very important here in the next couple groupings that we do. You also, I want to distinguish the difference between a drop beam and a flush beam. And they're exactly as they sound. A drop beam sits underneath the joist, whereas a flush beam is going to be on the same plane as the joists. Flush beams are required to be the same size, same depth, or larger than your joists. Your beam design. When you're doing a multi-ply beam, which the deck detail covers 2-ply and 3-ply beams, there are single-ply beams in the code book, and they are perfectly code compliant. However, they're outside of the scope of the deck detail. The beams may overhang past the center of the post, so just like a joist, they can overhang past the center of the post up to 1/4 of the span, but in this case, it's the actual beam span. So this is the total beam span, not just bearing to bearing. You also have a specific method in which the beam has to be built up. When you have a 2-ply beam, you only have to fasten it from one side. You're doing the staggered pattern, 16 inches on center as it shows up top, 1 inch minimum from the ends, and you're using 10D nails or number 10 3-inch wood screws, minimum of 2 rows. If it's 3-ply, you have to fasten it from both sides. The reason you have to fasten it from both sides is when you have a screw or a nail, it's only got a head on one side. So fastening it from both sides engages both the outer plies to the center. Now, if you were to use a through bolt, it's already engaging both sides. That's why you don't have, that's why it doesn't matter which side you're drilling from, because it's engaging both sides. Table 3, your minimum beam size. It's a little small, and I apologize. It's just a lot of information on here, but if you look in your deck details, you're going to find it on table 3. So if we have a deck that's 12 foot by 10 foot, no cantilever, so we'll use a 10-foot joist span. You're going to come over here to your 10-foot joist span, or I'm sorry, you divide that joist span by 2, and you get 5. So you're going to come down here to 5. That's your beam influence width. And you're going to come over here to 12, and it's going to tell you your minimum beam size is 3 2x10s. That beam influence width that we talked about is going to be half the distance from support to support. So, we're going to do another skills check. If you guys could go ahead and check it. Okay, so our longest beam span is 8 foot. So we're going, and then when it comes to that beam influence width, it's 8 foot because we have half the distance for the 12 foot plus the 2-foot cantilever. So if we had a beam at the back of the house, you would have just the 6 foot because there's no cantilever, but the beam on the out in the yard is going to have that 8 foot because you have that 2-foot cantilever. And that's going to give us, 2 2x12s or 3 2x8s as an option. So, footings and posts. This little statement right here is always a fun one. When less than 5 foot from the house, footings must be at the same elevation. And what does that mean? That means if you have a full height basement, that footing, if you design a house that has a footing within 5 feet, you might be required to go 8, 9 feet into the ground. As long as you are more than 5 feet away from the house foundation, your footings have to be, at least in Fairfax County, at least 24 inches below grade, and they have to go to solid bearing soil. So when the inspector comes out and do their inspection, they're going to come out with a probe, and they're going to probe that hole to make sure that it's solid. If it's not solid, it's going to be very easy to tell. That probe's just going to sink right into the ground. So they're going to come out, they're going to verify it. If it's good, they pass it, you move on. If it's not good, you might have to go deeper. Unfortunately, I've seen some footings go, again, 8, 9, 10 feet into the ground. And sometimes you still can't find solid soil there. And you end up having to go with a engineered design or a design by a registered design professional. So that's not to say that you can't do the project. It is absolutely outside of the scope of the deck detail. But there are situations where you just can't find soil that works. Another instance we run into is coming up to a hole like this, where as you're digging down, you run into your Comcast lines or you run into other possible utility lines. What I want to make sure you understand is it's only when you're trying to pour the footing over top of those lines that it's an issue. They can be in the same hole as long as they're not being utilized as part of the footing. So if that footing stops just below that Comcast line or Verizon line, orange is orange, orange is communications, you're good. Now, if it were at the bottom of the hole, absolutely not. You don't want to do that, because if you mess up that utility line, that's a lot more costly than you're going to want to have on the project. When we're sizing our footings, we have 2 charts that we have to worry about, Table 4 and Table 5. Table 4, we're going to use the same measurements that we used on the last one. Could have, your beam influence could be up to 18 foot. We'll do a simple 10-10 here, but if you go to 10-foot beam influence and over to a 10-foot beam span, you're going to get a footing type F and a max post height of 11 feet. Now that post height is based off of a 6x6. That's not to say that you can't go any taller than 11 feet. It's just outside of the scope of the deck detail. And then we go to Table 5. On that last one, we had F. Your footing size is going to be a minimum of a 22-inch square or 24-inch round footing, at least 8 inches thick. Footing sizes are actually very important, and it is definitely possible to oversize a footing. You would think that bigger footing is better. But if you make the footing too big, if you make the profile too big, you have something called a punch factor that you have to worry about, where you're just not utilizing the entire footing. So those sizes are fairly accurate. That's not to say that you can't go a little bit bigger, but those sizes are fairly important for other factors. When you're attaching the footing to the post, we have 3 accepted methods in the deck detail. There's 6 in the code book, but in the deck detail, we only approve 3 of them. One is with a mechanical connection, or actually the first 2 are with mechanical connection, and the third one is completely submerged in concrete. As I was saying earlier, there's a lot of, especially with footings, there's a lot of other methods that you can use. We have helical piers, which are starting to become popular in the county. But helical piers are an engineered product that require a lot of other things. A lot of times they require a soils investigation to make sure that the soil can hold the resistance that's required. They also require third-party inspections, so somebody has to be there to watch them be installed. We have other products like this footing pad. It's a perfectly code-compliant product. It has an evaluation report. It would be allowed per design. However, if I remember correctly, these footing pads, even the largest one they have, holds 4,000 pounds, I think. So if you have a really big deck, that's not going to be a viable option unless you're adding a dozen extra posts. And then we also have this new product that's called a diamond pier. It's really cool. You drive those pins into the ground, and it achieves actually a really surprisingly high resistance. However, not in the deck details. So a wooden patio wouldn't require a building permit, but anything that has footings and beams and posts, even if it's only 18 inches off the ground, it still requires a permit. So your post size and post to beam connection. When we're talking about these posts, we're talking about, like I said, we're talking about 6x6s. You can buy an 8x8. You can use a PSL. There's lots of other engineered products out there you can use. Deck detail is based off of 6x6s. The only time you're allowed to use a 4x4 for your deck post is if it's less than 30 inches in height. And when we talk about post height, we're talking from the bottom of the beam to the ground. So there's other situations where we're talking about the walking surface of the deck to the ground. But when we're talking about post height, we're talking bottom of the beam to the ground. Now, another one that is in the deck detail that is normally not a fan favorite to practice is treating all cut ends of posts. When I first got into this industry, I was led to believe that this stuff right here was more expensive than gold, but it is cut and treat wood preservative. All you do when you cut the post, you just slap this on top of it. It helps it helps to protect the wood from early decay. So yeah, the cut and treat wood preservative here. And it's anything that contains the copper, that copper compound. You also are going to attach the beams in these next couple of figures that are on the next slide. And then you can also mechanically fasten them. So right here, you'll see with a 6x6, you can notch it to connect a 2-ply beam. A 3-ply beam cannot be notched. You only are left with, I want to say it's maybe about ½ an inch on a 6x6. It's not a strong enough connection. Or you can use the mechanical fasteners. What you cannot do is do a split beam. That used to be a very popular connection, and that's not to say that you couldn't get a registered design professional to design a deck with a split beam. It's just not in the deck detail. And it's actually prohibited in the residential code. So if you were to use that connection, it would have to be through the commercial code. So that is to the 2018 code. That's a change that was added, that you can't have that shear connection there. If we're sizing this deck again, what size round footing would you need? It is type C with a max post height of 14 feet. If we come to the fourth one and we're looking for a round footing and we go to type C, we see 18 inches. So very good. Ledger attachments. Probably, oh yes, probably the number one. That and guardrail post attachments are probably the top failures on decks. The ledger board shall be at least the depth of the joist, not less than a 2x8. So again, if you design your deck with a 2x6, you're going to find yourself with some more challenges than you may have anticipated. And then the top of the ledger board and the top of the deck joist have to be at the same elevation. You can't, if there's going to be a difference in elevation, it'll be at the bottom, not at the top. Approved ledger attachments. So you can do your ledger directly into the band of the house. You can do it into a solid foundation wall, whether that's solid masonry or concrete wall, or you can do it into hollow masonry. Prohibited ledger attachments. You cannot go into engineered wood trusses. You absolutely cannot go into brick veneer. And you cannot go onto an overhang. You cannot reattach to something like this. It is, not only is it not allowed, but it is unethical. Don't do it. And you cannot, no matter, for the overhang, you cannot attach to an overhang. So what do you do here? What do you do in this situation here where you have the overhang that goes across the whole house?
Make it freestanding and dig the piers as deep as the basement.
Absolutely. In this situation, it looks like you are at the basement level, so hopefully it's not that far. And brick veneer. Like I said, not only is it not per deck detail, but you typically run into a lot of issues with brick veneer just because brick veneer is not a structural element and it cannot carry any other weight. And even in a situation like this, with that, with this BVLZ, it's still, you know, they're having to find ways to take all that weight off of that brick veneer. That's why it has this central piece here that kind of tries to alleviate the compression of the brick veneer. So a lot of times we'll get designs that try to work around, you know, that, and it typically becomes a more involved process. Flashing. The number one most important thing you can do to extend the life of your deck, properly flash it. When you flash a deck, it has to go over the ledger. There's a lot of contractors like to put it behind the ledger as well, and that's great, it's extra, but it is required to be flashed over top. The idea is, and this is even for freestanding decks, we get a lot of people that will do a freestanding deck and they'll still nail that board into the house, even though it's a freestanding deck, and it still has to be flashed because you are putting a hole in the house. You punch a hole in the house, you have to protect it. So we have the plastic flashing, which is fairly common. You have, which is this right here. You know, you just nail it up underneath the siding, and it's, you know, got the nice little lip there, and it covers that. And I don't remember exactly what this costs, but it's fairly affordable. Or you can do there's other plastic or composite flashing material. Again, you just have to make sure that it's not going to react to the pressure treated chemicals. If you use copper, you can still use copper. Copper with copper nails. You have to remove the house siding. There is no exception to that. Now, if you have a situation like stucco, where obviously that it is the side, it is the siding, or you have a situation with concrete, you have to caulk. You're going to end up caulking that behind the ledger to try to protect it as much as possible. So, your ledger fastening. One thing that's fairly unique to the deck details is these 4 fasteners at the end of your ledger connection. Now, this isn't the end of the entire ledger, it's each ledger board. So if you have a 20-foot long deck and you have 2 pieces at the ledger, wherever it breaks, you have to put 4 more fasteners at that end. You have lag screws, which are probably the most common that we see for ledger connections. You have through bolts, and then you start getting into your engineered products like ledger lock screws or the SDWS screws. Those are all going to be your wood fasteners. And then you have expansion anchors and adhesive anchors for those solid mason, the solid and hollow foundation wall attachments. When you go to get your footing inspection, most inspectors also want you to verify your ledger connection at that point. You can do that several ways. If you have a situation where you can show the inspector from the inside, say an unfinished basement, a crawl space, something, if you can show them from the inside what material you have, whether it's a 2x lumber or it's an engineered wood product, great. What we see a lot of contractors doing is they will take a hole saw and cut a 1-inch hole or 1.5-inch hole so they can show they can just hand the core sample to the to the inspector so they can see it and go ahead and verify it. But you need to do that before you put your ledger up so that they can see, that yes, it came from this house and yes, it is what you say it is. Now, you could put your ledger up if you do have that way to show them from the inside. It's just going to depend on the situation. But this gives you your spacing between fasteners. Now, as you can see, you can get to some almost impractical spacing depending on how big that deck is. 4 and 5 inches, that ends up being a good number of fasteners. That's a couple boxes of screws there. What do we think? We have a maximum spacing. We have 12-foot joist span, and the band board was confirmed to be 2x material. 12-foot, ledger lock, 2x lumber, 6 inches. So that means, depending on how wide that is, yeah, you have you could rack up a box pretty quickly.
So 6 inches between 2 screws?
Yep. Now it's it'll end up being staggered. You have 2 rows staggered,
Okay,
but
what's the 29 above this?
that would be if you were using through bolts. So yeah, if we go and look at the other measurements here, if you're using lag screws with 2x, you could go 15 inches. If you're using through bolts, and again, the difference between the through bolt and the lag screw is you have tension or compression from both sides. You could go up to 29 inches. The other, if you're using the SDWS screws, you're at 11 inches, and then for the masonry or for the foundation wall attachments, you're at 29 and 24 inches. So the question was about through bolts. Yes, that is going to absolutely be your best connection. And even though you do have to go back and tighten them, you get the option of tightening them. That's really the way. It isn't a permanent solution. It doesn't, even though it does need to be retightened, it can be retightened, as opposed to some of these other ones where eventually it's not going to work anymore because you're relying on one side to do all the work. How many people here have walked across a deck, an older deck, especially your grandparents' house or an older relative's house, and that thing, you get about 3 steps out on that deck and you just want to turn around and go back in. I know I've been on several decks during an inspection, not necessarily new ones. Most new ones are tight. A lot of these requirements are there for the longevity of the deck, not just for the immediate security of the deck. When we think about these deck codes and we think about these deck requirements, not every failure is a catastrophic failure. Not every failure is going to lead to your ledger falling off of the side of the house. A lot of it is also to do with the longevity of the deck. It's a big investment, these projects that you're doing around your home. You want them to last for a while. So some of these codes, even though they seem excessive, they have to do with the longevity of the deck. Your lateral support is no different. When you first put that deck together and you've tightened everything down and everything's secure, and it's probably not going to move that much. But in a year, after that wood has had time to swell and shrink, and it's going to start to move. And in 5 years, it's going to move a lot if you're not putting in some of these lateral restrictions. In the deck detail, any deck that has a post height, and now we're back on post heights, of 2.5 feet or less does not require the lateral support. Once you get above 2.5 feet, we have 3 methods that you can utilize to meet some of this lateral resistance. So from 2.5 feet to 11 feet, for single span and multi-span decks, you can use method 1 or method 2. And when you get to freestanding decks, it's method 2 or method 3. And method 3, excuse me. Up to 14 feet, and the deck detail only goes up to 14 feet. For single span and multi-span decks, you have to use both method 1 and method 2. And then for freestanding decks, you have to use all 3. And what are these methods? Method 1, tension ties. These are 750-pound fasteners that look like this. This is an example of one. This is the DTT1. And essentially, what you're doing is you're attaching it to the joist. So on the other underside here, and this screw goes into the bottom plate, not into the band, but into the bottom plate to tie the joist back into the house. Now it can also go on the side depending on exactly where your elevation falls. We have the 3 examples here where you have some tolerance there to try to achieve that connection. Method 2, knee bracing. This was the used method for a very long time. 2 foot out, 2 foot down. You're connecting, you're either using 2x6 members or 6x6 members. If you use 2x6 members, you're putting them on every post. 2 foot out, 2 foot down. If you're using 6x6s, you can get away with just putting them on the outside posts at 3'7" down, or 3'7" in. And then method 3 is the same as method 2, except for you're also doing, instead of just doing it parallel to the house, you're also doing it perpendicular to the house. So this is coming back on the end joists as well. And then attaching the bracing to the post. You have, you can either use 20D nails, or you can use those ledger locks or the SDS screws, or you can use through bolts or lag bolts. This situation probably comes up every single day. The only place in the deck detail that allows a recessed fastener anywhere is in the connection at the knee brace for a through bolt. That is the only place that a recessed connection is allowed. Everything else is not allowed per deck detail to be recessed. It comes up a lot because contractors want to wrap the deck in PVC. It makes it look good. It's easier to install if you're able to recess the fastener, but it is not approved per deck detail. And it is never allowed on a 4x4. I don't care if the engineer submits a design. We will not approve it. Anytime you have a deck height to the floor, the deck floor, more than 30 inches from grade, it is required to have a guard. Now, we get that measurement up to 3 foot from the deck. So you go 3 foot out in any direction. If it is more than 30 inches, you're required to have a guard. The guard that is spec'd out in the deck detail is made from 4x4s with 2x2 balusters, guard caps, and a maximum 6 foot span. You can use an engineered product, something, say Trex or somebody else, Decorators, I think has some guardrails. You can use those. You just have to make sure you provide the evaluation report. They may allow you to go with longer spans. They may have one thing most of those do not have is the attachment of the guardrail post to the deck. Most evaluation reports do not have that in there. Another popular trend is surface-mounted guardrail posts, which are not in the deck detail. And the reason why is the attachment details have been all over the place. A lot of evaluation reports don't include them in the installation instructions. A lot of them don't have them in the evaluation reports. Some of them just say, hey, you have to have a code-compliant connection to the deck. So those, if you intend on using a surface-mounted guardrail post, you have to submit a design. And this right here is where that 30 inches comes from. On the one side of the deck, there's a fair to good chance that you're at that 30 inches, but obviously there is a huge hazard right there. I've seen multiple situations with that happening. So the question was in reference to hot tubs or built-in benches. Both of those aren't per county deck detail, so they would require a design. But the code used to require, up until the 2015 code cycle, it used to say that you had to have your guardrail, when you had a bench situation, that guardrail had to be that much higher than the bench. That has been revised to the walking surface. They no longer consider the bench a walking surface. So it would still only have to meet that 36 inches. So if it's an 18-inch bench, it only has to go up another 18 inches. The hot tub is kind of going to be the same situation. You still have certain, well, no, with a hot tub, you're going to be above that. I was going to say you have certain restrictions for hot tubs, but if it's up on a deck, you're going to be above that requirement. Yeah, so it'll be part of a design, but those surfaces, it's based off of the walking surface of the deck. Your guardrail post connections. Do not notch a 4x4 for any reason. There is absolutely zero reason to notch a 4x4. The reason why is as soon as you notch that 4x4, it is no good. Notching the post used to be very popular, but there was a lot of testing done at both Virginia Tech and I believe it was University of Washington. And the conclusions that they came up with doing all this deck testing was that is a huge weakened point, and it is almost, if not impossible, to get a code compliant connection once you notch it. The other favorite for guardrail post connections is this hanger, or this fastener, this mechanical fastener here. It's the DTTZ2. This hanger is required to achieve that connection. It's not the only way to achieve that connection, but it is the only way per the deck detail to achieve that connection. And as you can see, well, any mechanical fastener that it has the same capacity would be allowed. Yeah, we don't only approve one product, but it has to have the same capacity. There's additional blocking that's required, depending on where you're at. If it's on the end, like this situation here, and you get lucky enough that it's right on the end of the joist, then you're only required to put one. If it falls somewhere in the middle, you're going to be required to have two in there, the two closest joists. On the sides, you have to install blocking. And not only are you adding this hold down, but you're also engaging the other joist, which is where all the strength comes from. You're now engaging multiple joists. So these connections, same thing. It's allowed per plan, but not per details. These are these surface-mounted guardrail posts. Again, they're gaining in popularity. They look really nice, but there's a lot of issues when it comes to information from the evaluation reports as to how they're supposed to be fastened. You also have your glass rails. Same thing, beautiful, perfectly code compliant, not per county deck detail. And then we also get a lot of wrought iron guardrails that people want to use, and looks beautiful. It's definitely stronger than wood, not per county deck detail. Stairs and landings. So, when it comes to the stairs and landings, you have a minimum width of 36 inches. Your stair geometry and opening limitations shall meet the requirements shown in this figure right here. When we're talking about a 4-inch sphere, this is approximately a 4-inch sphere. It's about the size of your fist. That's your opening limitation for rises. And then when it's also the opening limitation for your guards. This is supposed to be smaller than your child's head, and that's where it all came from. Trying to protect the wee ones. Your stair landings can be constructed out of 4x4s up to 8 feet. That's the only other place in the deck detail that you can use that 4x4 as a post. And then your landing widths have to be as wide as the stairs served. So, stair construction. You have to have bearing. So for your stairs landing on a landing, you have to have a minimum of 3 inches for your tread depth, or your riser depth on that connection. For your landing onto a set of stairs, you're using a mechanical connection that looks something like this. This is the same fastener that you see on the screen there. It has to be bent. I'm trying not to bend it too much, but has to be bent exactly. You nail it to the landing, and then you put your riser in here, and it'll get nailed and supported just like it shows in there. And then at ground level, it has to land on a landing. You have two options for doing your stair risers. You have cut stringers and you have solid stringers. Your solid stringers, you can go up to 13 feet. However, there's a little bit extra work going into it, whereas your stair stringers for your cut stringers, it has to be a minimum of a 2x12, and you're only allowed to go 18 inches max with wood. Once you start getting into your composites, you might find that you need more stringers. I know the 5/4 composite material requires stringers as closely as 9 inches. So double what you see here in the deck detail. So again, it's very important if you're going to use anything other than wood to make sure you're reading those evaluation reports. Your stair guards are going to be constructed in the same way that your stair stringers are. You still have the hold downs and the blocking. The bottom of the guard to the top of the tread can't allow the opening for a 6-inch. It's a little bit bigger, but you have that triangular opening there, and it does end up becoming a common mistake because when you're setting that stair guard, that angle can make a huge difference. It's also, you also have a maximum of 6 inches from support to support. 6 feet, I'm sorry, 6 feet from support to support. And then handrails. Handrails are required on any set of stairs that has 4 or more rises. That's not 4 or more steps, that's 4 or more rises. So if you have to pick your foot up more than 4 times or more to get to the top of the stairs, then it is required to have a handrail. That handrail is required to be continuous from the bottom of the stairs to the top of the stairs. If you have a landing, that is considered the top of the stairs. So that is a break in the stairs. It also has to comply with these profiles here. All that has to do with gripability of the handrail. Just because you can get your bear paw around it doesn't mean that your child or your parent can get theirs, and that's why, that's really who they're, who we want to make sure, everybody's taken care of. The other important thing to note with these handrails is that they return back to a guard post or a wall. I don't know if you've ever had to deal with a deck that did not have a return, but you will snag it 30% of the time. All right, skill check. Design a 20-foot wide by 16-foot deep deck. Make it ledger attached and make the 36-inch wide stairs from the right of the deck. There you go. The question was, is there just one solution or are there many solutions? The point of this exercise was hopefully to highlight that you can design this deck, especially with these general parameters, a dozen different ways. It really just depends on personal preference. It depends on, comfortability, whatever you want. But the deck detail, the whole premise of the deck detail is to give you flexibility and options. So there's probably 8, 9 different ways you could design this deck. And generally I try to get at least 2 different answers. But I think I may have seen a couple different answers in the when I was walking around. So, inspections. You've designed your deck, you've got your permit, and now you're going to inspections. You're going to have a minimum of 2, but possibly 3 inspections for your deck. You'll have your footing inspection, and for that inspection, you're going to have your holes dug. You're going to have another thing that the inspections department requires when using the deck detail is that you have your deck detail on site and filled out. Those last 2 pages that you were just using to work on for the last example, Those pages are required to be filled out and on site for your inspections. That way the inspector can come and verify everything that you've decided or assumed for your deck, and they'll be able to verify that, yes.
It also needs to be in plus, right?
The question was, does it also need to be in plus? When you're using a deck detail, you actually don't need to submit plans at all. You just let them know that you're using the deck detail. That's one of the benefits of using the deck detail, is that you just let them know that you're using the deck detail, and hopefully, as long as your plat's correct, because you also have to submit a plat, as long as the plat's correct, they'll issue you your permit, and the first time that you talk design at all would be with the inspector on site at your footing inspection. So you're going to call in your inspection, you're going to have your holes dug, and you're going to have, if you are using a ledger attachment, you're going to have that verification prepped and ready for the inspector. So they'll come out there, they'll have their probe, you're going to show them your paperwork from the detail. They're going to take a look at it. They're going to go over it, go yay or nay. They'll take a look at your footings, probe them, make sure they're good to go. Take a look at your ledger or the rim joist to make sure that it's the material that you're assuming it is. And then you're going to pass. Once you pass, you're going to place your concrete in your footings. You're going to attach your post. You can even backfill your footings at that point. You're good to go. You're going to frame everything up. You're going to attach your ledger. You're going to frame everything up. If it is 48 inches or more above grade, you can finish everything and call in a final. If it is 48 inches less, or you're planning a deck that has a bunch of PVC wrapping where you're covering all your connections up, then you're going to want to call in a framing inspection. At that framing inspection, the inspector is going to come and verify all your connections, that you used all the right bolts, that you used all the fasteners that are in the deck detail, that all those are detail compliant. And once you pass that, then you will finish everything up, and the inspector will come out for the final inspection. And at that point, the inspector is just verifying like your electrical requirements, your lighting requirements, grading. The final inspection, if you have a framing inspection, should be a fairly quick inspection. And now that you've been to this class, you're not going to fail an inspection. So yeah, two to three inspections, and you're good to go. If the inspection fails, the inspector is going to write you a report talking about the items that they saw that need to be corrected. And once you'll have the opportunity to correct the items. Once you correct those items, you'll call them back. They'll take a look at those items and pass you, and it'll be like nothing ever happened. So, well, thank you very much. That is all I've got.